Hello, I'm Brian Welch, aka Phoenix Nova. Okay, so like me, you've been thinking about or have actually purchased a 3D printer already. And the wife sees it as a toy. Okay, so maybe you have printed a couple of fun things. I mean, certainly you started with your test print. You printed a couple extra bearings for your spool holder. There was that frog that just didn't quite make it. Sure, you printed your Marvin keychain and that cute cat. Then you really started going hog wild and started printing out a ton of those open forge dungeon tiles that are magnetically attached and that you can slide around any way that you want, create anything that you want with them. So we have been using it as a toy, or in reality, as part of our hobby. And it is a great hobby. I mean, 3D printing is fun. It is a hobby with continued expenses, though. Filament, updated parts for your printer, other printers. And how do you justify this to your wife who still sees this all as a toy? Well, I mean, there's a lot of things that are hobby related that also are tools. I'm sure that you've had family, or your significant other or wife has had family where they have table saws, circular saws, belt sanders, an entire workshop set up. And that very many times can be a hobby, but at the same time, they use it to fix things around the house or build things specifically for the house. We can use the 3D printer for the same thing. In fact, you have a little bit more flexibility with it, because not only can you go to some of these websites and find specific tools that you might be able to use around your house, but with a little bit of patience and some software, specifically CAD software, you can actually design your own devices to use around the house. Things that are going to be specific to your home and your situation. Things that you can present to your other members of your household as this is more than just a toy or a hobby, that it can help around the house. So the best way to show this is to give an actual use case. In my household, my wife has an iPad mini, and she likes to lay down in bed and browse the internet with it, or Facebook, or anything else. Well, the frame of the bed is metal, and the backboard of the bed is metal. And in fact, it's metal slats going across. So if she shifts her weight the right way, the iPad falls down behind the bed. There's a really good chance of hitting metal. And this actually happened once. Fortunately, didn't damage it. So I wanted to create something for her where she could safely use the iPad in bed, conveniently, and not worry about it falling behind. So what I'm going to do is I'm going to go step by step through using a CAD program online that's it's a beginner CAD program, but it's still pretty powerful. It's called Tinkercad. And I'm going to go through Tinkercad and design the iPad mini holder that I created specifically for her and our situation and our household. Hopefully this inspires you to design your own things in your household. For right now, let's get started. All right, here we are in Tinkercad. Now, Tinkercad is an online CAD program, so you'll be able to create objects directly online, save them online, and download the STL files. Now, Tinkercad has a number of tutorials that you can go through, and they'll teach you a lot about how to actually use this. I'm using the beta version of it, as you can see right up here. And while I'm going to at least show you what you need to do, or what I am doing to create this particular device, I'm not going to go through everything that it can do. Suffice to say that Tinkercad works on the idea of shapes and adding those shapes together to make a greater whole, including using shapes to make holes. So we'll get into that as we go. Now, you always need to start off with a good plan so that you know where you're going to be making things, changing things, how large to make things. Now, one of the things I discovered was that the back slats of my headboard
were about 33 millimeters in depth. So I need something that will be a little bit bigger than that to hook over the top. And I looked up the dimensions of an iPad mini, so I had some basic idea there. So mostly what I'm going to do is I'm going to do pieces that are all 4 millimeters thick. And we're going to go ahead and start on the top lip, or the top hook that goes over the headboard, work our way down, and then we'll work on the surface that the iPad mini is going to be laying on. So almost everything I'm going to work with today is going to be with a box. It's going to be the easiest way. So you can just click and drag a box out. It's automatically going to lay down onto the work plane. You can manually change, for instance, the height or the width and the depth by the various little tool handles that you can grab. You can also use, as I spin this up here, there's this little triangle up top pointing up. That will actually raise it up and down off of the work plane. That's going to be useful later on. Also, you can rotate in the various ways, and we'll use that in a little bit. Off to the right, especially in the beta of Tinkercad, you can directly put in some of the dimensions. So I know, for instance, that I'm going to be starting with 4 millimeter height, and this is going to be kind of the hook. We're going to have the hook end of this, the flat piece that goes over the headboard, and then down. So this is going to be the hook part, and I happen to know that that's going to be about 14 by 4, so 14 inches in length. Oops, got to hit enter afterwards. There we go. And that's just going to be a little hook that's hanging down to make sure that it doesn't slide off of the headboard. Now we need the top piece, so we just drag out another box. I'm going to zoom in a little bit here so we can make sure that just lining these up a little bit on some of the grid lines so that we can make sure we line them up correctly with each other. So again, almost everything is going to be 4 millimeters in height. And in this case, I know it's going to be about 35 millimeters wide and only 4 millimeters tall. Now you can drag this around with your mouse. You can line it up as you move around. Or you can also use the arrows, and it will move it a specific amount based off of the snap grid down here. So I'm moving it by 1 millimeter. That allows me, in this case, since I'm staying on 1 millimeter, to make sure that they're touching. This is going to be useful, or very important rather, coming up here in a minute, when we join these pieces together. So I'm going to zoom out a little bit because now we're going to get to the longer piece that's going to come straight down and lay across at least the top and next slat of the headboard. So drag another box out. This piece, we're going to go with the 4 millimeters in height. We're going to make it 10 millimeters wide, and I kind of measured everything out already, so I know that I want this 180 millimeters tall. And we just use our grid to line this right up. There we go. Almost wasn't close enough there. There we go. And we got the vertical piece. You can also select everything by drag and drop, so I can move them up and to the side a little bit. Now, since this is going to be a profile of the piece that we're working with, the iPad is going to be laying against this. Well, if you're laying down in bed, you don't want this vertical, especially on the headboard like I have, which is a vertical headboard. So you want a bit of an angle here. So we're going to have another piece that the iPad's pretty much going to be laying on. And we're going to go ahead and make that, it's going to be a little bit longer since it's at an angle. So it's going to be 187 millimeters long. And we're going to keep it with the 10 millimeters wide. And that's going to become important for being able to snap this together. Now, since we wanted this at an angle, you can click on this, and if you click and drag. If you stay inside the circle, it jumps by a set amount. If you go outside the circle, it's very much more granular. In addition, you can just click on it and come over and click exactly what angle you want to put it in. Now, what I want here is I want a pretty nice, meeting of these two objects up here. So I'm going to move them around a little bit and see they're a little bit off. So I'm going to go ahead and change my snap grid to 0.1 millimeter until I just kind of get those corners roughly lined up. I mean, this is small enough that the granularity of our printer isn't going to matter too much. Since I'm done doing that, I'm going to make sure I move that back to 1 millimeter in case I have to move anything else. So we got a nice angle to lay the iPad down on. What we need to do is for, of course, structural integrity, we've got to make these two pieces solid down the bottom. So we're going to bring out another box. This will be kind of our base here. Again, only 4 millimeters high. This one's going to look a little bit different because I determined I needed about 51 in length and about 16 in width. Oh, got those backwards. There we go. And that's going to just cover these up a little bit. What I'm doing is I'm just trying to get it so it covers this piece, gets down to the bottom of this piece, maybe a little bit extra, as you can see here. There's a little extra overlap. And that's going to be coming clear why I'm doing that in a second. So we've got a nice corner down here, but we don't have a nice corner down here. It's kind of chunky on us. So let's make something custom that will fill that out. Of course, 4 millimeters in height. And our width, we're going to kind of eyeball this. Let's say that this is 8 by 8. And we just want something that is going to, now maybe we need a little bit bigger there. Not quite big enough. Let's just say that, let's put the width up to 10. There we go. We want something that, and maybe take the length down to 6 there. The reason why is because we want to continue down the angle, but we want to kind of chop it off there. And maybe we'll move that back to 8. You'll see why in a second. Okay. So, since we wanted the continuation of the angle, we're going to have it also rotated just like we had rotated the other piece. So it's still 15 degrees. Oop, that did not go to 15 degrees. Control Z is our friend. Let's try negative 15. There we go. That gets us so that we can marry up that angle a little bit. Now, I could have also done this just by making the other piece longer. I'm just going through the same process that I did before. The big thing is we want this corner at or below the level of this other piece over here. Make sure our face lines up pretty good over here. There we go. So that lines up. This is at or below that level. Maybe we'll just go a little bit more down just to be safe here. So we got the angle. Now we got to come across. Well, what we can do is we can pull out this box instead, which is automatically a box that is a hole. I can shrink that down to our 4 millimeters. And actually 4.5 is fine. Change this back to 1 millimeter. And I'm not too particular about the size of it because the only reason it's here is to kind of chop off that little bottom piece sticking out. Again, easier way would probably just make this piece longer. But sometimes you need to be able to marry some pieces together like this. So this will be a good example. So I can take the smaller piece, shift click on this larger piece, and I hit this little button up here to group them together. And all of a sudden, we've got our bottom corner. Yeah. And actually, it looks like it's just sticking out just a little bit. So we can ungroup this and maybe move that up 0.1. Oop, that's moving both of them up. Make sure you're clicking only the one you want to move. Okay, group them back together. There we go, much better, much closer. Okay. So what we have there is our completed side piece. Except that we have no way to put the other pieces on it. So what we're going to do is we use our hole again. Now, see, with the holes, I make them 4 millimeters high. It doesn't matter too much. It just needs to intersect enough that we can make sure the hole goes all the way through. So 4 millimeters would be fine, but I usually make it a little bit bigger just in case. Actually, let me delete that one and let's bring one out with our 1 millimeter snap grid set up. So I'll make it 5 millimeters, and I'm going to make it 4 millimeters in width, and it's, the 20 millimeters long right now, and that's fine. That doesn't matter because we're just going to use it to chop out holes in 3 different places along here in order to put in the cross members to snap it together. Now I make it 4 millimeters in width because I'm going to do 4 millimeter holes in the other side, and we know each of the height here of each of these things is 4 millimeters high. So we're going to have a 4 millimeter wide hole to fit around the 4 millimeters of material here. I'm going to take this and I'm going to go Control C, Control V, and again, so I have 3 of them, and set that at the 15 degrees. Oops, minus 15 degrees. So then it matches up with this and it's got a nice angle. Now, I want each of these to have about 5 millimeters. Since this is 10 millimeters wide, I want it to go about 5 millimeters deep in. And I want to do it somewhere where there's a little bit more material. So basically just put it close to the side. It doesn't have to be perfect, but we know that it's going to go about 1 millimeter increments. So we just go 1, 2, 3, 4, 5. And we don't have to be perfect about this because we are going to print 3 of these. And because we're printing them from the same template, all of these are going to be automatically in the same place. We want that about in the middle. And we want this one there we go. Want this one down near the edge somewhere. You got to remember it's going to be going in a little bit at an angle. So 1, 2, 3, 4, 5, and then I'll just bring it down a little bit, and that's pretty close enough. 1, 2. So, and it is an angle, so it isn't going to be perfect, but it'll do very nicely. Want that somewhere in the middle of those 2. Bring it in until it touches. Oops, that changed size. Let's just delete. Make a new copy. Bring it up somewhere in the middle. There we go. That's about halfway in, as you can see. So now we got this piece. Select everything, group it all together. Automatically, you have a side piece that's going to go over the headboard, one of the slats. It'll lay against one of the other slats down here, also was measured, and it'll have pieces that slot into those 3 notches. Let's go ahead and move that off to our side, and we'll work on the pieces that will be notching in both in the middle and the top notch. It's real easy. Bring out a box, change it to 4 millimeters. And this is important that it's 4 millimeters here because it's actually going to go, I mean, technically, it's going to go, let's move it this way, up on end. Oops, spin it the wrong way. It's going to go up on end like that. And it's going to have its own notch notched out of it. And it's going to come in and slot in to these. Which you'll be able to see. Because we'll just go our -15. Right? And it's going to be a piece that's slotting right in here. And it's got to be fairly close to the same size. And it's going to have its own notch so it can go a little bit deeper and have a pretty much buy a 5 millimeter by 5 millimeter overlap and pretty much cover that entire 10 millimeters to lock these two pieces together. So that's why it's important to have that 4 millimeters. Let me delete that and we'll just bring a whole new one out. Okay, so 4 millimeters tall. And we want it that base 10 width, because we're going to take that 5 millimeter chunk out of it. In this case, I figured about 178 millimeters wide was good enough. So at this point, we've got a piece that's going to slot in here. Now I could just slot in there just like this and it'd be fine. But there would only be 5 millimeters and it would only be, this clamping around this part. There would be nothing clamping, you want to clamp on both directions. So that's where holes come in. So grab that center one, bring it down to 5 or so. And again, you want this 4 millimeters because you want it to match the height of the other piece. And you can just leave it at that length, that's fine. And make your copies. Now what I figured is I was okay with a little overlap. That's why I have the 178. So I figured at least a 4 millimeter overlap. So all I have to do is line it right up like that, go 4 up, and 5 in. 2, 3, 4, 5. And I have that one in place exactly where I want it. We do the same thing up here. Line it up. As long as we're marginally close. It's like it's maybe 1/10 of a millimeter off there. You can fix that if you wanted to. Change it back to the millimeters. So 4 down. 1, 2, 3, 4, 5 in. 1, 2, 3, 4, 5. Now, you could count out the grids here and try to get this centered. You could eyeball it. But, both those things don't sound like a very fun way to do it. Fortunately, there is a much easier way to do it. To be on the safe side, what I'm going to do is I'm going to group these so those all stay together and we have our holes. I'm just going to bring this over here and bring it to where it touches. I don't even know if that's centered or not. So I'm going to click first on the red piece, then on our hole. I'm going to go up to a line up here. And this brings in a whole bunch of different dots. Line it to the top, line it to the bottom, center them one way, align them other ways. I want to center it like that. And that's going to put it right in the center. And then all I have to do is go 5 in. 1, 2, 3, 4, 5. Now what I do is, because I come back and I change things and I might set up different ways of doing things, I might change the design. I don't want to have these different groupings at different levels. So what I do is I go back here and I ungroup this again now that I know that the red piece wasn't going to move separate from the holes. So now I'm grouping the holes with my main piece all together at one time. That way, anytime I go back to make a change, I can just click on this, ungroup them, move these around however I want, and then regroup them. So I only grouped the original time just so that as I moved them, it didn't change one piece relative to the others. It kept the two holes at the two ends together. So now we just got to create the bottom piece. Now the bottom piece is more than just a piece that locks in. One, it has to be wide enough to hold an iPad mini, and an iPad mini in a case that is going to, that the front cover is going to open and it's going to wrap around the back. I measured at its widest, it was 16 millimeters. But the other part of it is that you're going to be pressing buttons while you're in bed. Well, depending on how you design it, here I've designed it so that you have 3 of these side pieces, really vertical pieces, fit in 1, 2, 3. So even if you push back, you're going to be pushing back against the center piece, and the iPad isn't going to fall through. However, you don't want to take that for granted. So you want to lip on this bottom part on the back end so that it kind of locks in a little bit and has something to push against. For that matter, you want to lip on the front end so it doesn't slide off the front. So we're going to start with our familiar 4 millimeters in height. And we need that 178 length so it matches the other pieces. So it matches the same length. And I figured the width would have to be 32 millimeters. That's to cover a number of things. So now we have to have some type of lip. So the front lip, now the height here is actually going to be 7. I have it 7 millimeters because I want it to be able to grab and keep the iPad from falling off. We already know the length is 178. And our width is actually where the 4 millimeters is going to come in, so that we keep that kind of nice 4 millimeter sizing with everything. So I can take this, put it over here, click on the bigger piece, then the other piece. Oh, looks like I already lined them up centered, so that's good. So now, all I need to do is grab this little cone arrow here, make sure I'm on 1 millimeter from my snap grid, and bring it up 4 millimeters. And I'm just going to use my arrows to get it lined up. That needs to go over one more. There we go. Now it's lined up with that piece. Now I need the back lip, but here's the problem, is we're going to have 3 holes in this. So let's make our holes first. Okay, I'm going to have 5 millimeter high, 4 millimeters width. We have 1 at the bottom, center, top. And we're going to align that to the center right now. Okay, all 3 pieces nicely aligned to the center. I can zoom in here, get it to where it touches. 1, 2, 3, 4, 5. Same with this piece down here, get it in touch. 4 in, 1, 2, 3, 4. 1, 2, 3, 4, 5. And then just get our last piece here. One, two, three, four. 1, 2, 3, 4, 5. Okay. So what I'm going to do is I'm going to merge or group just the holes in that bottom piece. So they stay together. The lip is still kind of separate. We'll merge the lip here in a second. So we need a back lip. But as you can see, you can't do a back lip the whole way down, because if you did, you'd cover up these holes and it wouldn't snap together. So the back lip has to fit in between these. I actually ended up measuring that out as being 78 millimeters. So we want 4 width. We do not want 4 height. We actually want a little bit more height. I put it at 10 millimeters in the back. And then 78 millimeters long. I need 2 of those. So one's going to go down here, and one's going to go up here. and you just line them up one at a time. Oop, Control-Z's our friend. Okay, and it has to be, let's get this other one lined up while we're here. There we go. There's a little bit extra. Looks like this could actually be a millimeter longer. Let's see if it's the same down here. Yes. So, make them 79. Now, when you change length like this, it's going to do it in the middle. So you're going to have to line it back up. Okay, it looks good. Go down to the bottom, lines up nicely. Alternately, what I could do, since it's lined up on one side already and it's a millimeter off on the other side, I can click on it, I can change my snap to 0.5 millimeter and hit up 1. So now it's 0.5 millimeter away from both sides. So when I resize it to 79 millimeters, it grows at 0.5 millimeter in both directions. As you can see, automatically just lines it right up. I think that 1/10 of a millimeter that I moved it was not a good idea. So I can ungroup, move this down to 1/10 of a millimeter, move back up. Probably was just the angle that I was at. We got everything laid out now, except that these lips, it's just in the back. It's not really hooked onto anything. What I want to do is I want to raise them, so I change my snap grid to 1 millimeter, raise them up 4, move them over 4, and that's where they're going to live. Get that last piece. And you can spin around, check it from the different angles, make sure everything seems to line up. Everything seems to line up. So you can just grab the whole thing and group it. Since I was wrong about that 1/10 millimeter piece before, I'm going to change this one back. I think it was just the angle I was seeing it at. So one bump up and regroup these. Okay. Now we've got the 3 different parts all built. The next thing you need to do, of course, is print it out. But to be able to do that, you need to export these out. Simply, I found it's best because you need print 3 of these, 2 of these, and 1 of these, that you want to hit export up here, select the type that you want. As you can see, when you hit export, you can say everything or just select a shape. I export an STL. And that gives you your STL folders, or excuse me, your STL objects that you can bring into your slicer and then print out.
And there you have it. Now you're going to print out 3 of the side pieces, 2 of the smaller cross pieces, and the bottom tray as well. All these pieces are actually designed to snap together. So it gets cross piece, fits right in. You just kind of press fit it in there. And some of them will snap in a little bit better than others. And you have a fully designed tool specific for the situation. In this case, hanging from the cross slats of the headboard. Now I also added some felt right up at the top here, and that's specifically to try to keep the noise down because it is going to be hard plastic against metal. And a side benefit with the way it was designed is that it actually stands upright. Now, my wife has her iPad mini with her, and she's not here right now, so we can just use my Kindle, which is actually in a case as well. And as you can see, fits really nicely, great for when it hangs. It's got a nice angle for when you sit in bed. Angle's not quite as great when you're sitting on a desk, but still serviceable. Again, I hope this inspires you to go out and actually create your own devices. Try to convince people that these 3D printers are very valuable and powerful tools. And hey, maybe just make something that you need yourself. And of course, continue making the fun stuff as well, because 3D printing is a fun hobby. I'll catch you next time. This has been Phoenix Nova. Bye!